Good morning. This is Alex Kuban. And I created the community center Scenic Designs for the Scarce Sustainable Design Challenge. To begin, I'm going to start with transportation and sustainable sites. Green transportation of my community center. As you can see on the front path of the community center, there is a walkway. Over in the parking lot, there are electric car charging stations for a more renewable source of transportation instead of gasoline cars. Next would be the heat island reduction. As you can see on top, I've included a green roof to the top of the main portion of the building as a way to reduce the heat island. I also have included like native plants and other like grasses and things around the outside of the building, along with trees and a shaded region as well. The light pollution is next. And to prevent light pollution, the outside lights from the balcony, as you can see, are pointed down within the balcony and are LEDs to save energy as well. There is also massive windows, including a windowed bridge between the two different sets of buildings, to have more natural light during the day rather than having artificial light, including skylights. And then also the inside and outside lights would be on a timer, and then the indoor lights would also be on a timer. The site development, the community center could be built near a playground. The site I had picked would be the location where the old Helen Plum Library used to reside, and I do this because you could replace that whole area with the community center, which is small in horizontal land but is more vertical. Secondly, we have stormwater management. First is landscaping. For landscaping, I have obviously on the outside native plants and species, including a row of trees between the parking lot and the site itself. The next portion, which is storage. For stormwater storage, I have the bioswale in the parking lot, which is, as you can see here, in the middle of the parking lot between the different places for them parking the car, and then also beneath the flowers. For the next portion, the runoff and absorption recharge. I have rain chains, as you can see in the front, to be the sources of drainage for rain coming off the balcony and other portions of the building, into rain barrels where they would be collected, which is another form of storage, to be used to water the other portions of the community center. Along with those, the permeable pavers on the path to the front of the community center and the parking lot itself also create runoff for water. For outdoor water use reduction, the water collected in the rain bills can also, like I mentioned before, be used to help water the garden inside. The storage of stormwater runoff from the rain barrels can be used for the garden, community garden on top of the second building. Other forms of indoor water reduction would be the inclusion of low-flow water plumbing, and including toilets that could have two different forms of flushing. For water, there would be water metering on all floors that could determine what each floor's water use is, and really make sure that water usage within the greenhouse and the building itself would be properly understood. Next is the energy efficiency. For the first is lighting. For lighting, I have on the top of the model, I have skylights to be used for natural lighting, including windows, along with the lighting would include LEDs for heating and cooling. In the underside of the model, I included a model of my geothermal heating and cooling system, which includes a closed loop vertical loop piping for on-site energy production. As you can see on the top of my model, I have wind turbines. These wind turbines are used to convert wind energy for the model. The wind turbines move or rotate to better catch the wind if it ever shifts from the fixed position that the wind turbines are in. Along with the wind turbines, I have solar panels. As you can see, there are smaller solar panels on the bridge, but there are also larger ones, including more solar panels on the top of the building on the green roof for energy usage monitoring. Again, just like the water metering, there would be energy measuring devices on each level. Within the community center, there would be automatic lights to make sure that the lights weren't left on or too much energy would be used. It would be energy efficient to have the automatic lights for every room, and then also have a timer on the outdoor lights for the times that the community center would need to be lit, and times when it would not need to be lit during the daytime, or if the community center was left off during the night. And then finally, the building envelope itself. The entirety of the outside of the building was created with massive windows. As you can see here in a diagram I drew, the building itself on site would be positioned to be facing southward, as this is the most energy efficient form of the building. But then also the building skylights and solar panels are set up to be east to west. As the sun rises and sets and goes across the sky, the solar panels will collect as much daylight as possible to be used for energy for the building itself. Next is materials and resources, the building materials used for the site. For the storage and collection of recyclables and or compost, as you can see, I included a small recycling bin on the side of the building that would be used to collect recyclables. There is a compost section within the model inside the greenhouse to best use that compost for gardening. Moving on, I have the use of sustainable materials. Now, the building itself would be created out of insulated concrete framing for the exterior, including the gray and white portions of the building that you can see here. And then within the building itself, instead of having wood flooring, instead there would be bamboo cork flooring, a combination of the two, to better help that. Use of eco-friendly paint and other sustainable inside materials to make sure that the building itself is insulated. In other portions of the community center, including the walkway and the separate smaller building, there would also be concrete flooring and recycled tile used within the bathrooms and other places which would require tile to create a more aesthetic feel. Finally, we would have the indoor environmental quality. Now we have the low emitting materials, which I've already spoken about, which would be the bamboo flooring and the recycled tile and concrete flooring, which would help combat the toxic emissions that would normally come from wood or other flooring or indoor design that would create a toxic environment for people. And then finally, the air quality features. As you can see in the front of the building, I have a very small no smoking sign. And then along with the air quality features, there would be air quality control along with proper ventilation, as I included, with some of the vents and windows on the outside of the building here and on the smaller building here in the front.